All right, guys. So previously we were looking at BMAT 2014, question 20, really talking about this problem, Pythagoras, a bit of trigonometry, but all in 3D. Hopefully, guys, me simplifying the problem in chunks of 2D wasn't too difficult, and hopefully you managed to follow up. But now, guys, we move on to BMAT 2013. Star question. So a few students probably got this question wrong. So it says a solid shape is made by joining three cubes together with the largest cube on the bottom and the smallest on the top, where the faces of the two cubes join the corners of the smaller cubes are at midpoints of the size of the larger cubes. This is the size of the smallest cube have a length of 1. What is the total surface area of the shape? So guys, pause the video, give yourself a minute. Be sure to be back after that minute, and then we'll be going through the solution. Okay, guys, so let's go through this. So we know the size of the smaller cube has sides 1. So what? That's 1, 1, 1. And so that means that the square, the surface area of that is obviously going to be 1, isn't it? Because the surface area of the square is just 1 times 1. But you would think that there's 6 of these faces. But remember, the bottom face is adjoining with the second cube. So you can't, because you can't touch that. So it's part of the surface area. So we have 5 of those faces. Yeah, 4 around and 1 on the top. So far we have surface area of 5. That's from the smaller square. Okay. The next thing we know is that this side is obviously 1. And remember, these are at the midpoints. So we have a little triangle there, little right angle triangle, right? So, and we know that since it's a square, that's going to be the midpoint there. That's going to be midpoint there. That's going to be the midpoint there. And since the sides of the square are all equal, that means that the midpoints are also going to be equal. So this length here to here and that length here to there is going to be equal. So I can just call those x. So I can actually say the square root of x squared plus x squared, which is basically going to be 2x squared, right, equals 1, which is the hypotenuse, right? And then square both sides, 2x squared still equals 1, x squared equals half, and then x is just a 1 over root 2, basically, right? We can rationalize that, but I think that should be fine for now. So we have that now. Now we need to work out the surface area of these kind of corner bits, and there will obviously be 4 of them. 1, 2, and then a third one that we can just about see, and then one really behind that. And obviously this is just over here, this triangle over here, just a right angle triangle with base and height 1 over root 2. So it will just be base times height over 2. And 1 over root 2 times 1 over root 2 is going to be 1 over 2. Divided by 2 is going to be 1 over 4. But remember, guys, we have 4 of those. So this is going to be that times 4, which is just going to be 1. Right, so far is that this is what we have. I'm going to arrow that as that going to be the calculation for our final answer. Now, guys, so we know that this 1 over root 2 is just half of this length here. So the full length is going to be 2 over root 2, double that, isn't it? So the full length, I'm just going to write FL, is going to be 2 over root 2. And again, guys, this is going to be, we have 4 squares here, isn't it? Right, and all the sides in a cube are equal, and 4, so the surface area of the area of one square, if you like, is going to be 2 over root 2 squared, or 2 over root 2 times 2 over root 2 is going to be 4 over 2, which is just 2. And you're going to have 4 of those, so 2 times 4 is going to be 8. So we add that 8 on, so we bash that 8. So now we've covered, yeah, so you have 4 of that. Remember, guys, because the top face, we don't really have a full top face because it's kind of joining with the small cube, and we don't really have a bottom face because it's kind of joining with the bottom cube. So now we got that. So now, guys, we know that this length over here, you already just talked about that here. This is going to be, what did we say, 2 over root 2, isn't it? And again, this is a similar scenario. We have a right angle triangle here. This is going to be x, if you like. That's going to be the same because it's, again, a square. All sides are equal. And so when you half the sides, they're still going to be equal. So then we basically get the square root of 2x squared equals that length over there, which is 2 over root 2. Square both sides, so 2x squared equals 4 over 2, which is 2. Then take the 2 across, so you're going to get x squared equals 1, and therefore x is just 1. So we get x is 1 as the side length over there. Okay, so now we have x is 1 as the side length. We can work out the area of this triangle. So it's going to be base times height divided by 2, so 1 times 1 divided by 2, which is just half. But remember, guys, we have half, but we have 4 of those, right? 3 that we can see and 1 behind. So half times 4 is going to be 2. Yep, yeah, it's 2. Okay, then what else do we have? Now we're dealing with these squares here, isn't it? So the squares here. So we know that x is 1, so the full length over here, now we know is going to be 2, right? So then that means the surface area of that square is going to be 4. But then we have 4 squares around, and we have the bottom. You must not also forget the bottom, right? So we have 5 of those faces, and each area is 4. So 5 times 4 is going to be 20. So plus 20, and now we just have to add this up. So 8 plus 2 is just the 10, plus 20 is going to be 30, and plus the 6 is going to be 36. So hopefully, guys, you can appreciate then in this answer, the answer would be D. So a bit of a long question, guys. Really, probably if I saw this in the exam, I might probably just going to leave it, come back at the end if I have enough time. Because remember, guys, it's only 1 point as with every other question. But nonetheless, guys, I hope this question has made sense, and we look forward to seeing you in the next question. All right, guys, so welcome back. So previously looking at BMAT 2013 question 20, talking about this question where we had to find the total surface area of this shape. So if you didn't manage to do that in a minute, guys, I know most of you guys, you probably know how to attempt this if you were given unlimited time, but if you couldn't carry it out in a minute, don't worry, guys, because this is really a difficult question, and even I would quite struggle to do this all in a minute. But remember, guys, it's only a mark. And within the time you can do this question, you probably can get 4 other marks on easy questions. So it's not to worry. But without further ado, we're going to move on to the next question, BMAT 2012. Again, a starred question. This is the triangle ABC shown below, not to scale. Tan A is a sixth, and tan B is 2/3. It says M is the midpoint of AB, and it says what's the value of tan theta. So guys, pause the video, give yourself a minute. Be sure to be back after that minute, where we'll be going through the solution. Okay, guys, so welcome back. So remember, guys, whenever you see this SOHCAHTOA thing, right? What you want to be doing is thinking about right angle triangles, because there are rules where you can work this out, like the sine. Remember the sine rule and the cosine rule, but those stuff you probably gonna need a calculator to figure that stuff out. So remember, you don't have a calculator, so the only thing that they can expect you to do is SOHCAHTOA, and obviously SOHCAHTOA you need a right angle triangle. Now we have tans of 2 things. We have of A, so this angle and this angle. Now a good idea that I can give you guys to work it. You're going to have to draw 2 triangles, one which incorporates angle A, one which incorporates angle B. But what you should try to do always, guys, is try to draw a triangle where they have a common side in common. So if I'm going to draw a triangle where this is the common side. So you have one triangle here, as you can see, right? And then you have one triangle here, as you can see, right? And now obviously the first one has A and the second one has B, and you'll see why this is useful now. So remember, tan is SOHCAHTOA, so O and A. So opposite is going to be here, and that's the right angle. That's going to be hypotenuse here, adjacent here, and then opposite here. So over is going to be, so you would think this is 1 over here, and then over, so it's going to be 6. You would think this one is going to be 6, isn't it? And then for the second triangle, now I have a conflict, isn't it? Because that's still, the O is going to be the same side, the A is going to be this one, but the hypotenuse is going to be here, right? So over A, this one now we'll think is 2, right? But A is going to be 3 in this case, right? But you see the problem here is the same side, but one of them is saying 1 and one of them is saying 2. So the way you sort out that problem is, remember, tan A equals 1 over 6 is just the ratio. It's the simplest ratio. So that could have been, rather than 1 over 6, it could have been 2 over 12. And that would have just simplified into 1 over 6. So what I can do then is, if I treat it as 2 over 12, rather than being 1 here, it will be 2, and that would obviously get rid of the confusing part. Now both the sides are 2, so that makes sense. And now this would be 12. And now we need to work out, it's asking us, guys, what's tan theta? So tan theta, we can just extract this triangle out here, draw out more clearly here. So theta is here, right? So you got that. And then obviously we got this, and then, yeah. And then obviously, guys, we know that this side is 2, isn't it? Now we just need to find, so remember, with tan, you have the hypotenuse, we have opposite, and we have adjacent. With tan, so TOA, we need O and we need A. So we need to find what this length over here is. So remember, so what we can do first, guys, A to B, the whole length over there is going to be 15, and we know M is the midpoint, isn't it? And if M is the midpoint, it's going to be half of that. So half of 15 is 7.5, isn't it? 7.5. And if I just call this point X, this X to B part is 3, so that means what's left from that is going to be 4.5. So it's going to be 4.5 here. And then if you do tan theta, then is going to be tan theta is going to be opposite, which is 2 over 4.5. But we don't like decimals in fractions, therefore you just times top bottom by 2. It's going to be 4 over 9. And this maps on nicely, guys, onto option C. So I really hope, guys, that has made sense. And as always, I really look forward to seeing you in the next question. All right, guys, so welcome back. So previously we were looking at this question, semi-difficult, BMAT 2012, question 16. But hopefully, guys, we have learned a load of skills that we revisited how SOHCAHTOA essentially works. And also I gave you an extra technique, guys, on how to solve these kind of questions where there's quite of a confusion. Like when you do SOHCAHTOA, one of them is suggesting a side is one length and the other one suggesting a side is another length, and how to fix that problem. So hopefully, guys, that has made sense. But now we're going to move on to the next question. So it says, if you look at a clock and the time is 9:45, and it says, what is the angle? What is the angle between the hour and the minute hands? So, guys, pause the video, give yourself a minute. Be sure to be back after that minute, and then we can go through the solution. Okay, guys, so let's go through this. So some of you might be thinking there's 9:45, so surely that should be, isn't that just, so if you imagine this is our clock, right, then you obviously have 12, 3, 6, 9. You're probably thinking 9:45, surely that's just the big hand is literally on top of the small hand, right? And therefore you think the angle between them is actually 0. But in reality, that's actually not how a clock works. So the hour hand moves, basically the hour hand moves with the minute hand. So basically, when it's 9:45, rather than the hour hand being strictly on 9, it will be 3/4 the way between 9 and 10, because it's like a quarter way left to going to 10, right? So rather than this, guys, it would actually more be something like, let's just imagine this is 10, right? It would be somewhat more like this. So there's clearly an angle there, so we need to work that out. The way you can work that out, guys, is we know the angles in a circle add up to 360, and there's 12 intervals in a clock, isn't it? So you just do 360 divided by 12. So 36, 12 goes into 36 three times, but you have 360, so it's going to be 30, right? So you have 30, but remember, it's not full. So it's not. So that's gonna. So from 12 to 1 is going to be 30 degrees. 1 to 2 is going to be 30 degrees, etc. But it's not. We want to work out the angle from 9 to 3/4 the way through to 10. So we need to divide, basically times this by 3/4, 3/4. And if we divide 30 by 4, it's going to be 7.5. And then we just have to times that by 3, which is going to be 21. So 7 times 3 is 21, and 0.5 times 3 is going to be 1.5. And that gives us 22.5, doesn't it? So hopefully, guys, you can see then that in this question, the answer would be D. So as always, guys, I really hope that has made sense, and I really hope you've actually, if you didn't know, you've learned actually how a clock works. But other than that, guys, see you soon. See you in the next video. All right, guys, so welcome back. So previously we looked at this question, BMAT 2011, talking about more or less how a clock works, and if you're able, if you knew how the clock works, I'm really sure everyone would have probably got this question right. But that was really the main idea of that question. Now, guys, we move on to the next question, BMAT 2011, question 20. This says the diagram shows three similar right-angled triangles. This is what's the area of the largest triangle? So, guys, pause the video, give yourself a minute. Be sure to be back after that minute, where we're going to go over the solution. Okay, guys, so welcome back. So yeah, we have over here three similar triangles, or another idea for similar is, the mathematical way of saying it is congruent. So first thing you can do, guys, the only thing you can really do here is use Pythagoras to work out the hypotenuse here. So this side over here, so that's just going to be the square root of 1 squared, which is going to be 1 plus 3 squared, which is going to be 9, and that's just going to be the square root of 10. So we know that now is going to be the square root of 10. And this is, these triangles are congruent, isn't it? So that means that the factor to get from here to here, which is going to be, well, divide by 3 times by root 10. If I do the same thing here, I can work out what this side is. So what I need to do to get that side is times by root 10 over 3. Right? And if I do that, yeah, I'm just going to get root 10 over 3, isn't it? So root 10 over 3. And then what I could do from there is work out the new hypotenuse out. So this one. So to work out that now, what I need to do is use Pythagoras again. So square root of root 10 over 3 all squared is going to be 10 over, what's it going to be, 10 over 9, right? And plus root 10 squared, which is just going to be 10. So if I square root that, let's just clean this up actually. So that's going to be 10 over 9 plus, I can say 90 over 9, isn't it? Right, like that. And then that's obviously going to be, add the two numerators, to be 100 over 9, and then square root top and bottom, so it's going to be 10 over 3. Right, so that's going to give me that. So now this is 10 over 3, right? Then, so times so we know the scale factor between the, since they're all congruent, you have the same scale factor between all of them, isn't it? So so the scale factor is root 10 over 3. So to get from here and this side, I have to times by another root 10 over 3. And if I do that, I'm going to get 10 over 9. Yes, that's right, 10 over 9. And therefore, to work out the area of that triangle, I just need to do 10 over 9 times 10 over 3, all divided by 2, which is going to be 100 over 27 divided by 2, isn't it? Which is going to be 100 divided by 2 is going to be 50 over the 27. So hopefully, guys, you can appreciate that. The answer you will map onto here is B. So hopefully, guys, that has made sense. And as always, we look forward to seeing you in the next video. All right, guys. So previously, we were looking at BMAT 2011, question 20, revisiting the idea of congruency again. But hopefully, guys, that idea now is really solid in your brains. Now, guys, we're going to move on to the next question, which is a starred. So that's just a warning signal, guys. BMAT 2010, question 24. There's a design is set up by joining the points which are 1/3 of the way along the sides of a square. This forms a second square as shown. The process is repeated. Calculate the area of the fourth square as a fraction of the original square. So, guys, pause the video, give yourself a minute. Be sure to be back after that minute, and then we'll be going through the solution. Okay, guys, so welcome back. So let's go through this. So, we're not really told what the length of this square is, but at the end of the day, guys, it doesn't really matter because when you work out the fraction at the end, it's not dependent on what initial length you selected, right? Whatever length you select, so I'll do it with one, guys, you could do it with another, you should end up with the same answer, really. So what I'm going to say, guys, is let's say this big square, the length is 3. Let's say that, and the reason I picked 3 would make sense in a bit. The reason I picked 3 because it says, so the ratio here is going to be 1 to 2 because this corner joins 1/3 along the length. So 1/3 along 3 is 1, and so the rest must be 2, um, and so on. So this one must also be 1. So the reason, right, guys, I really picked 3 is so we can work with more manageable numbers. So we have 2 and 1. So you can just use Pythagoras to work out the length of this side here. So you do square root of 2 squared, which is 4, plus 1 squared, which is 1. So it's going to be square root of 5. Right, so now we know this is the square root of 5. Now, this process is going to be done again. So you have here, let's say, let's try this out. Hopefully it doesn't end up as a disaster. But yeah, we'll try this out. Yeah, I think that's actually going to turn out a bit okay. So you have that, and then you have that. Okay, and then now this is again split into 2 to 1. So then over here, guys, you're going to have root 5 over 3, and the rest is going to be just that times 2, isn't it? So 2 over root 5, right? So here we're going to have so that length there is root 5 over 3, and then this length over here is going to be root 5 over 3 times 2, so 2 root 5 over 3, right? And again here we're going to have root 5 over 3. Okay, and then so now we have that. Now we can work out what this length is, isn't it? By again just using Pythagoras, right? So if we apply Pythagoras to that, it's going to be root 5 over 3 all squared is going to be 5 over 9. Plus 2 root 5 over 3 all squared is going to be 4 times 5, which is 20 over 9, right? And then we just have to square root that, right? And then square root that is going to be 25 over 9, and square root top and bottom is going to be 5 over 3. So now we know this length is 5 over 3, and then that process is repeated once more. So if you do this again, once more, what you're going to end up with is something like this. And then if we just fill in, and also, guys, remember, in the exam, it doesn't have to be pretty. But the reason I'm just taking my time here is for you guys to learn and understand why why the answer is what it's going to be. So you have 5 over 3, but again, you're going to split it into 2 to 1 ratio. So if you split it up into 2 to 1 ratio, the one part is going to be 5 over 3 divided by 3, which is going to be 5 over 9. And the other part is just going to be that times 2, which is basically going to be 10 over 9. And therefore, we have another angle there. So to work out this hypotenuse here, so h is just going to be the square root of 5 over 9 all squared, which could be 25 over 81, plus 10 over 9 all squared, which could be 100 over 81. And we just have to square root that. So that's going to be the square root of 125 over 81. I'm just going to leave that then as square root of 125 over square root of 81 is just 9. And then that's obviously just the square root of 25, square root of 25, square root of 5, isn't it? Over 9. So it's going to be 5 over 9 root 5. So that's going to be that length there. So the area of the last triangle, so if I shade that in this triangle here, so I'm just going to do that. So that shaded part is basically just going to be 5 over 9 root 5 times 5 over 9 root 5, which is going to be 25 over 81 times 5, isn't it? Which is essentially just going to be 125 over 81. Basically, I didn't really have to, it's basically just this value, isn't it, guys? So I could have just saved time by noticing that earlier. So we have that. So that's the area of the smaller triangle, but we need it as a fraction of the original one. So the original one is going to, remember that we set the value as 3. So the area of the original one is going to be 9. So what you need to work out is 9 divided by 125 over 81. Right, so we need to do that calculation now. And if we do that calculation, guys, what we're going to get is, so this is going to equal, if we times both sides by 81, so it's going to be 728, I think, 720, so times top and bottom by 81, right, is going to be 729, yeah, 729 over 125. And also, guys, I realized I got this wrong. It says calculate the area of the fourth triangle as a fraction of the original. So it's the smaller divided by the bigger. So it should be actually the other way around. Therefore, you get 125 over 729. So my apologies there. And therefore, guys, the answer you should be getting as a result then is C. So quite a difficult question, guys, I admit, in terms of how long it is, and it's easy to make arithmetic errors. But either way, guys, hopefully my explanation and hopefully my diagram, which seems to look quite nice, has helped you. And as always, guys, really look forward to seeing you in the next video. Right, guys, so welcome back. So previously we looked at BMAT 2010 question 24. Again, quite a difficult question, and hence why it's a star. But hopefully, guys, with my explanation, that has made a lot of sense. Now, guys, we're going to move on to the next question, BMAT 2009 question 8. So it reads, a cube has unit length size, i.e. basically the length is just 1. What is the length of a line joining a vertex to the midpoint of one of the opposite faces, the dashed line in the diagram below? So guys, pause the video, give yourself a minute, be sure to be back after that minute, and then we'll go over the solutions. Okay, guys, so let's go through this. So this kind of question, guys, is awfully common. Whenever you have this sort of work out the length of this line, in the line kind of in 3D, what you're basically aiming to do is form a right angle triangle in 2D and work from that. So the easiest one I can form, guys, is this one here. So there, there, and there. Right, you can see that's a nice right angle in there. And we know this thing has unit length, isn't it? And we need to work out, essentially, we need to work out this length here. So that means this is 1, but we don't really know what this length over here is, the one that I've just indicated. So we need to work that out, right? But we can do one thing. We can make another right angle here, and you got a right angle triangle. You got a right angle triangle there. And what do we know from this now? So we know that I haven't obviously drawn it exactly correctly, but this should be half in terms of scale. I haven't drawn it, and that should also be half. But hopefully you can appreciate that, guys. And therefore, if you use the Pythagoras theorem, this length here is just going to be the square root of half squared, which is a quarter, plus another quarter, because that's a half squared again. Square root that is going to be square root of basically a half, isn't it? Which is going to be 1 over root 2. So that length there, guys, is 1 over root 2. And therefore, to work out the length, the question mark is just going to be another Pythagoras with 1 over root 2. So it will be the square root of 1 over root 2 squared is basically 1 over 2, and the 1 over there, so plus 1. And that's going to be the square root of 1.5, which is basically 3 over 2. So essentially, this is going to be, square root of 3 over 2. So hopefully, guys, you can appreciate then that the answer here is going to be B. So hopefully, guys, that has made sense. As always, we look forward to seeing you guys in the next video. And actually, in fact, I think this is actually the last question on the geometry series. So the next time we'll actually see you guys is in a completely different video where we'll be looking at measure in the next series. So hope to see you then.